Are your videos public?
Yeah.
Oh,
Which is always, YouTube. You always get somebody to stumble across your stuff that wants to scream at the world. All right, so what's this have to do with it? What we've been doing up to this point with variable expressions is multiplying them, adding them, all that kind of stuff, right? Dividing them even. But we haven't actually done that. We haven't factored them yet. Oh, shit. So, for example, if I have something like this from the last section, what would you do? Distribute. Yeah. So what do you get? 8x squared minus 6x. Now that's where I get, see how many terms I got in the answer? 2. How many terms did I have here? 2. Okay, you can't create terms, right? That's the next level of biology of these things. All right, so what we're getting into now is to do that whole thing backwards. So for example, this is chapter, I think it's 7, right? So we're so now we're going to have something like this. What do you got, Jeff? I don't know. Oh, 10y cubed minus 25y squared. And the instructions will be factor this. In fact, this kind of factoring has a very specific name. This is not the best example. But can I take one y out? Can I take one y back out of both of them?
yes.
Okay, and why am I saying it like that? What did I do up here? I had a 4x and a 3, and I gave them both a 2x. So don't they both have a 2x in them?
Yes.
I could take a 2x out and kind of go this way instead. That's what we're going to do. Right? Now I could take one y out, but is that the most I could take out? No. How many y's could you take out of both? 2. Now he can give how many? He could give 3. But if you try to take 3 y's out of both, what's this guy? He's going to freak out. Right? So this is kind of like the fair tax man. I'm going to take a bunch, but not more than you got. Right? All right. So I know I can take out a couple of y's. And another way to look at this is, what would somebody have multiplied in? How many y's would somebody? Well, 2. They both have at least 2 y's. And what about the numbers? What number do they have in common? 5. So if I can take a 5, I can undistribute. That's another way to think of it. I'm just undistributing. So first I have to figure out, what do they both have in common? The biggest factor they have in common, the greatest common factor. That's the name of this factoring, affectionately known as GCF. Greatest common factor. If I put that down there, what's left here?
2.
Yeah, 10 divided by 5 is 2. I had 3 y's, I took 2, so I have 1 left. Minus 25 divided by 5 is 5. I had 2 y's, I took them all. And how do you check your work?
You distribute.
Distribute, yeah, and you make sure it actually goes back to where it started. Same way I would check the 18. I would just multiply what I got at the end to make sure that it actually was 18. Okay, I like it. I'm certain that at least some of you must have seen this before, if not all of you, right? This kind of idea. Here's the really cool thing that you don't get to see too much. This is going to become even cooler when we learn more factoring, which for some of you is not cool at all, I understand. What could y be? It could be anything. So I can make y anything. Let me make y 2. I'm about to do more than the problem needs. I'm done. That problem is done. Everything I'm about to do is extra Jeff shit, right? But it's a beautiful way to check your work, and it's a beautiful way to see what's really happening. Why, if y is 2, if y was 2, what's 2 cubed? Times 10? 80. What's 2 squared?
4.
Times 25?
100.
100. So if y is 2, that number is negative 20. You with me? If y is 2, what is the result? 2 squared is
4, 4.
times 5,
20.
20. 2 times 2
4
minus 5.
minus 1.
Isn't that that's a very basic way, but isn't that a way to factor negative 20? 20 times negative 1? So, I want you to realize the reason that this is harder than factoring 18 is 18 is one number. How many numbers does this represent? An infinite number of numbers. So when you factor this expression, you are factoring an infinite number of numbers. Holy shit. What did you do today? I don't know, sat around and watched you. I factored an infinite number of numbers. Thank you very much. You don't have to do anything in black up here. That's all extra stuff, right? And again, if I picked another number for y, this would be a number and this would be a way to factor it. So that's the concrete idea behind what we're doing. So, what about this guy? What you guys have? I don't know. Yeah. You start to see some shortcuts for the idea. Doesn't change the idea, it just makes it quicker to apply. Where am I at? Way there? No, I'm there. The numbers should be relatively easy. The numbers are just numbers. We're used to working with them. What's the biggest thing that goes into 16 and 20?
4.
And a really nice, this doesn't always work exactly this perfectly, but how far apart are 16 and 20?
4.
So 4 is a good candidate for going into both. If 4 doesn't work, then some factor of 4 might go in like 2 or something. Do you have to know what I just said? No, but it is kind of nifty. So I can take a 4 out. What's the shortcut for figuring out how many variables to take out? Can I take 4 m's out? No, so you always take out
The least.
the lowest power you see on that variable. So for the m's, I'm going to take out
3.
because all the terms can give 3. Some of them are lucky and have some left over. That's good for them. What about n's?
2.
2. And also notice, this is a little tiny detail. Do you see how I'm trying to put that over a little bit so I can see this becomes here and that becomes there? Because when you write this here, people sometimes write there and forget about this guy. You know, that's a little thing about how you write it could be evil. So don't be evil to yourself. That's my job. So what do you have left here?
4.
4?
And
Yeah, I had 4 m's, took 3, so now I got 1 left. I had 2 n's, took them both.
5.
20 divided by 4 is 5. I had 3 m's, took them. I had 4 n's, took 2, so I have 2 n's left. How do I know I'm done? No, not how do you know it's right. So that's good. To check it, I would multiply back in. How do I know I'm done? Because there's nothing inside that's like anymore. There's no common factor to both, right? This guy's got m's, he's got n's. He's got a 4, he's got a 5. There's nothing left. So if you would have taken out 2, there would have been an 8 and a 10. There's still another factor of 2 you could take out. So you could do these in steps, sort of like reducing fractions. You could reduce a fraction in steps. So you don't have to figure out the biggest number right away, but you do have to make sure you go all the way. All right, how are we doing so far? So this is not a horrible introduction to factoring because it's distribution in reverse. You're just thinking backwards. All right, so let's try this. Okay. Where am I at? 3. Let's do this. Where am I? Good old MAB. Backwards is Emerald Math. Bam. This one's got a little, so this has got 2 kind of freaky things. Notice there's more terms But do you realize how we don't give the first shit about that? I don't care how many terms I put down. The process is the same. It is a little bit, you gotta be careful, because the number you pick has to go into all three numbers. But we're kind of used to that type of thing. So obviously, what goes into all three numbers?
2 and AB.
Here, hold on, we're gonna catch you. So 2, put it over here a little bit. And then the lowest power I see in the M is 1, the lowest power I see in the A, and the lowest power I see in the B. So, that's the next weird thing, is it looks like I just took that whole term away, but, so let's go. 40 divided by 2, 20. Had 5 M's, now I got 4. So I'm just gonna lose one of each, right? So I'm gonna lose an A, I'm gonna lose a B. 6 divided by 2, 3. Lose an M, lose my only A, lose a B.
Plus 1.
Now, here, exactly, but what's wrong? Somebody will do that because they're like, well, I lost that last term. But if you distribute this, do you get back to that? So there's 2 ways to think about this. Either you need a placeholder 1 so that when you multiply through, you do get that back. Or even better, what's frickin' this divided by itself? Frickin' 1. I like it. So there's 2 reasons why the 1 is there. I like it. And if you require 3 reasons, I don't care. I'm not gonna give it to you. So that's one little thing to be careful about is you never lose a term. You need some kind of, at least some kind of placeholder, so when you multiply it, you do get back to where it came from. All right, now I'm gonna, you know me, here's the next level of this. See what you guys think. Yeah, it's gross. I like it a lot. Now, let me ask you this. Almost never will you multiply when the problem is factor. Those are exact opposites of each other, right? Factoring means tear it apart. Tear it apart. Multiply means put it together. So I'm not going to FOIL that thing out. That doesn't make any damn sense. Do you see something? How many terms are up here?
2.
Beautiful. This one is. And of course, what do they both have in common?
X plus
Dan. No, let me say this. Let me make sure you guys see this. I don't see an X up there anywhere. I don't see a Y up there anywhere. And I think most of you guys said this right. I see an X plus Y, right? He's got a couple X plus Y's. He's got one X plus Y. So I can take out 1x plus y. So what's left here? 4 times x plus y. And then here, he lost his x plus y. I'm all sad. And here's why I said earlier, you almost never multiply, because the one thing you can do now is simplify the inside of this. The factoring step is done, right? There's nothing left common, so I can simplify, get in there, that business. So this is where we got to start realizing that this is a single number. If I knew x and y, if I knew x is 1 and y is 2, that is the number 3. So that is one thing. So it's going to act like one thing. Yes?
On like a quiz or a test, if we left it,
You would lose a point,
so we have
depending on how much the points are at.
So we have to like
Yes,
simplify the
I like
inside.
it. Yes, you
Okay.
must. Yes. Because if this would have been like a 2 instead of a y, there would have actually been.
No. For
Yeah.
like, if you put the answer that the second.
That's what I'm saying. You gotta go to this next step
Okay.
because, for example, not even because of this, because you just have to. But if that was a 2, 4 times 2 is 8. I could put that together with the 7. So that's one reason why we simplify inside something, if the factoring is all done, is to see if there's any like terms that we can further put together. In this case, there wasn't, but oh well, we had to do it to check. Yes?
What is it, for the 4, why did you put the x plus y in front of the?
Watch this. You ready? You ready? Let me put the same problem, but a different problem at the same time. What you got, Jeff? Doesn't matter. There it is, buddy. All right, those are the same problem. Those two problems are the exact same problem. What's x plus y? Do you know? Sure, okay, I love you guys. You're a little ahead of me. We don't have a clue what the hell x plus y is. So I can call it g if I want to. Doesn't it say 4 times something I don't know squared minus 7 times that thing? Doesn't that say the exact same thing? So however that works, this should work the same way. So this is much easier, isn't it? What can come out of these two? 1g. So I take a g out, and what would be left?
4G.
4g
7.
minus 7. Now if g was x plus y, same answer, right? So the x plus y is a single thing. This had 2 of them and this had 1 of them, so I can take 1 of them out. So the idea of GCF doesn't care how much shit's in this little thing, it just looks at it as one big thing.
So you would simplify the G with the problem, right? After you did.
To check it,
Yeah.
you could undo what we did, which is to multiply that back in. Right? So to check this one, what's x plus y times 4x plus y? 4x plus y squared. And what's x plus y times negative 7? Negative 7x plus y. Yes?
You're only taking out the variable on that one because you can't take.
Yeah, the 4 and the 7 have nothing in common.
Okay.
Yeah.
So that's the only reason why it's just a variable.
Beautiful.
Okay.
Yeah. The other ones I was making, the numbers have commonalities. I just want to focus on the freaky part. Yeah. So let's see. So here, how do you do this one? What do you got, Jeff? So again, how many terms are up there? 2. Is there anything these two terms have in common? They have some x minus 5's in common. How many could I take out of both and not freak either one out? 3. Right? So if I take out 3 of these, if you wanted to, you can even use haha. You don't have to. I have no idea why I was. So this guy had an A and 4 of these, now he's got an A and 1 of them, because I took 3 of them out. You can talk to yourself just like that. You can say that to yourself. Sit far away from people if you have to say it a lot. So x minus 5 plus, yeah, he had 3 of these, I took all of them. So all he's got left is little b dude. And then the last thing I can do, since the factoring's all done, then I can clean this up a little bit. Do you need to do what? Sorry?
Like to do x minus 5 then x squared plus 5x plus.
Oh, hell no. Yeah. I'm sorry. If the instructions, now again, what's the instructions on all these problems? It would just say factor.
Not complete.
It would say factor. Factor. If I start multiplying, like if I start multiplying this, I'm doing the opposite of what it wants me to do. Now inside, you could, I'll multiply, but what am I really doing inside? Simplify the inside of this. That's fine. But don't go multiplying this out. If I said factor 18 all the way, and you do all this work, and then you do one more step and you put the 3's together, shit. You made it and then you went away from the answer. Ah, damn. So the only time you want to multiply is if you're doing this one little last step of simplifying the inside of something. You definitely don't write this 3 times and start foiling, because that is multiplying. That's the opposite of factoring. Okay, maybe. You guys love this shit, I can tell. All right. So, last thing for today. Then we'll head out. Yeah. Let me see. Okay. You can do it, Jeff. There you go, buddy. All right. This is Funkadelic, right? Just stare at that sucker. So the instructions would say factor. So based on what we know at the moment, why does it look like I can't do anything? Does all four of them have,
Because it's just like one equation.
does all four of them have something in common?
They're all
No.
adding.
So I can't use GCF directly. So this is the next level of factoring. How many terms are there? 4. And eventually, once we learn more levels of factoring, I'm going to give you a sheet that summarizes all the levels and gives you an idea of when to use which form, when to do what, right? So when I see 4 or more terms, I try to do something called grouping, which is kind of like 2 GCF problems in one. So let's pretend like this is a problem and this is a problem. So that's the grouping. So what comes out of these two?
X.
X. And what's left?
4
Plus
plus 1 plus
Plus. What comes out of these two? Yeah.
8.
A. And what's left?
4x plus
Okay. Now how many terms have I kind of
2.
reorganized this into? 2. There's only 2 terms. And what do they both have in common?
4x plus 1.
Yeah, so I can take out 4x plus 1, because they both have that. And then what's left?
X plus
X plus A. All right. This is a new idea. There's nothing that this should tell you to expect to do this. There really isn't. But I'm telling you, when you see 4 or more terms, and there's not anything that comes out of everybody, you try grouping. What does grouping mean? I put the first pair and the second pair together. Yes?
What if that was mixed up? Could you still do it?
Yes, I love it. Let's try it. So what you're asking is, this is
Faster, actually.
Huh?
Would be faster, actually, if you mix.
faster.
Faster
No,
to the result.
not really, but let's try.
No.
So if I mix the middle 2 up, let's see if that'll even work. Yeah, that'll. This is neat. All right, here we go. There are ways you can reorganize this where grouping doesn't work. So it does have to have certain things together. All right. But notice how I just switched the middle 2. Let me ask you this. In this line right here, which piece is inside 4x plus 1? Which piece is outside? Okay, keep that in mind. What do I do here?
4x.
4x comes out.
X plus 8.
X plus A. I like it. Now here's nifty. Is there anything that comes out of there?
No.
You're wrong.
1.
4.
1 comes out. So you can always take a 1 out. And why do I want to do that? I'll show you. So then it looks exactly like what we're used to. See how that looks? That looks exactly like what I'm used to. What do they both have in common now?
X plus 8.
They both have an X plus A. And then what's left?
4x plus 1.
And notice what happened. Did I get the same answer?
Yeah.
Yes. Just here, what was inside?
X plus 8.
And here it was outside. What's outside here?
4x plus
And here it was inside over right there. So I just switched the middle, so I switched where the things were, but the DNA has to be the same at the end because they both are the same problem. So it's got to come out the same at the end. Just in the middle, it's all reorganized, but who cares? It comes out at the same at the end.
How'd you get the answer?
I forgot. Oh, all right. So right here, I got 2 terms here, right?
Yeah.
1, 2. What do they both have in common?
X.
Let me stop right there. Does this term have an X?
No.
No. The same way that 9 doesn't have a 4 in it. Does 8 have a 4 in it?
Yeah.
Hell yeah. Does 9 have a 4 in it? No. And don't say, no, it's 4 plus 5. Because when I say in it, I mean multiplicatively, right?
Yeah.
So this term has no x.
Oh, yeah.
This term has a 1
A one.
and
An
an x plus a.
Yeah.
So nobody has an a. There's no a's in here anywhere. And I know I have somebody. Somebody must be thinking I'm insane. Or more insane, right? But there is no a. There is no a. There's an x plus a. Shit, yeah. There's no a's. I don't see any a's anywhere. Aw, Jeff, mean teacher. So they both have an x plus a. So I can take that out. I can take it back out.
Oh,
And then what's left? You can literally do what I've been doing.
oh, 4x plus 1.
Yeah. How do you check yourself? X plus a times 4x. Bam. X plus a times 1. Bam. Check yourself. Show me what you want. And real quick. If x was 2 and a was 3, I'm curious now. I just made that shit. I have no idea what this is going to be. Right? This is sort of like what you did earlier. This in black here, this is extra shit that you never have to do. That would be 4 times 2 squared. So this would be 4 times 4 is 16. Yes? Yeah, okay. Plus 4 times 3 times 2 plus 2 plus 3. So what number am I working with? 45. What's x plus a? 5. And what's 4 times x? 8 plus 1. Is 5 times 9 a way to factor 45? Yes. Do you see that? That's one concrete example of this very abstract shit that we're doing. We're working with numbers that we don't know. So how many actual numbers am I working with right here? Infinite number. So to kind of check yourself, you can pick values and see if what you got is a way to factor this. What you got. It's just my 18th puberty. All right, they never stop coming, kids. Those puberties and your actors, man. And you never get past that. Sorry. Just to let you know. All right, that's plenty. Anybody come in and didn't get their test back? When they emailed, well, they sent it back. I gave them an expiration date. Maybe there was miscommunication in their office.
No, yeah, no, I scheduled it the same day as taking the other test, and then when I got there, they said that there's no.
All right, because they had sent it back to me.
Whatever you want, I can do the test when I get it.
Yeah, so I'll send it back. Just send me an email, remind me.
Yeah, I
Okay.
can do tomorrow morning, if you'd like,
Anytime. I'll see it.
or Friday, whatever day.
Yeah. Just send me an email anytime, and then I'll tell you when you can take it.
She forget.
Uh-oh.